Welcome to Gary Keep It Simple. Often on Facebook groups, amongst various things you see people asking about is this problem. A Chrome Music Cassette. What's the problem, you may say? Now, if you think about it, that can really make the brain hurt. Which seems to be at least some of the problems some people have. Why is it a problem? Well, why do they have a problem? Mostly it's because they are trying to use it to do something it wasn't intended for. They want to record on it. The thinking problem is this. This is a Chrome Type 2 tape. It is in a reasonable housing or shell. So far so good. Then they look at the shell, and because they are of an age, they realise that the shell does not have the autosense for Type 2. The Type 2 cutouts. WTF? At this point, the confusion really sets in. This is a Type 2 tape in a Type 1 shell. That means it's not compatible with my machine. Wrong. The only reason they think that is because their machine has got auto tape sensing. Now they think that this machine is going to be fooled by the cassette. And in a way they are right, but is it a problem? Well, the answer is no. Not if you're using it for what it's intended for. To understand this problem, we need a bit of a history lesson. Oops, not quite that far back. Because this is, wait for it, Gary, Keep It Simple. What I'm about to tell you is absolutely right. However, it's not precise and totally accurate. Let's face it, if you could simplify every complicated subject, there would never be any complicated subjects. Okay, let's start. I shall try to keep it simple and short. Once upon a time, a man invented electricity by passing a coil over a magnet. Then he passed big coils over big magnets to make big electricity, and the electricity networks were born. Magnets and coils, the same principle as tape recording and playback. They started off with wire. Now you see here there's a very nice picture of a United States patent for one of the very first wire recorder. Then they went paper tape with rust, iron rust glued to it. And from there they progressed to plastic tape. And various other metals, all of which have magnetic properties, were made into rust. That's oxide to you and me. They discovered that the smaller they made the metal particles, the better the frequency response, and the lower the hiss. Note, hiss is a metal particle passing by the magnetic pickup, which we call the head. As each particle passes it, it makes the head respond. The reason it is hiss, not a thump, is because it is in fact a thump. A very quick thump. A very small, short thump, which we hear as hiss. Hiss by definition is high frequency. The small particles also give us the benefit of allowing us to imprint the shorter bits of magnetic pulses. That means that higher frequencies which are shorter can be recorded easier. They fit snugly onto the bits of rusty metal. To show the picture of tape and frequency, now this is not to scale, but you can see there is a difference between the top waveform and the bottom waveform. And if you were to look at a magnetic tape that's been recorded, you would see with a tone a pattern similar to that. Now the trouble with recording is that the tape is not linear. In its response to the magnetic field, it is more sensitive at different frequencies. And that means if you try and record directly onto the tape, you'll get a result but it will not sound very real. It will be very crude. To give the signal a chance, you need to give it a boost. This boost is called bias. The DC bias as used on new cheap cassette machines is a way to do this. It is, in my opinion, not a good way, but it's better than nothing. Just. AC bias was developed, and this does the same thing, but is much more subtle, and gives the gorgeous effect you hear on any good tape machine. They supply an alternating magnetic field that the audio signal is added to, and that is put onto the tape. The AC sort of softens the magnetic resistance and allows it to be magnetized much more easily and more consistently. The bias is not actually recorded, it is too high a frequency to go onto the tape, and so therefore it cannot be replayed. However, the audio signal is delicately put on the tape almost exactly as it was supplied. Now, this is where it is necessary to try and keep it simple. What follows is true, but may be very simplified. Trust me, it's better that way. You need to understand this bit. Depending on what the rust stuck to the plastic tape is made from, will determine the exact amount of bias needed to get the best results. You want to be in the middle of a slot of reaction. Too much and it will top out, too little and it will bottom out. Just right and you have the sweet spot. Just think Goldilocks and the Three Bears. Think Goldilocks and the Three Bears when she was trying the beds. So far so good. Now you have to make more than one machine. The trouble is others know this, they also make one. Then they discover that the frequency response is still dire. Much better than it was, but it's still not good. The engineers from all the manufacturers add a bit of frequency adjustment. The bass is low so they boost it, the treble is low so they boost it. This is the sort of thing that you're looking at on this chart. This is from the RIAA. This is what they do to records to try and get the best sound. Now America decides to standardise on the amount of boost. Unfortunately, it's not the same amount as Europe. Similar, but not the same. Japan has its own ideas. We now have machines that all work the same way, but are all not compatible with each other. You cannot exchange tapes. They all work well on tapes they produce, but if you play them on the other machines, they sound odd. The cure was simple. Standardise the settings worldwide. This they did. They call it a time constant. For type 1 it is 120 microseconds. This has been decided. It offends no one and gives a good overall result. So on playback you reverse the action, giving it as near as you can a flat frequency response. Nearly flat. It can never be perfectly flat. Then comes along type 2 tape, Chrome, etc. This is able to hold the magnetic energy slightly better. The rust powder grinds up smaller and the particles hold the magnetic signal stronger. So the freeze response is naturally able to be higher. All good so far. The hiss is lower, but it is different to the type 1. It costs more to make. It is not exactly the same magnetically. It is a bit more sluggish to get going. The bias is now not strong enough. The particles need a bigger push to get to the best response. If you're selling a machine at a premium price and the tapes at a higher price, you need to get every ounce of improvement out of the tapes and the machine. Also, you need an excuse for the public to buy into it. Type 2 tapes were a lot more expensive than Type 1. This is a picture of the Argos catalogue, 1983. It's really blurry, but you can see all the tapes there are being sold for about $2.99. Type 1's 3 for $2.99. Type 2's 2 for $2.99. Obviously this is a very blurry picture, but you can make it out. For the same money you only get 2 Type 2's. That means in today's money the Type 1 was £3.45, whilst the Type 2 was £5.17 each. The cost of equipment, decks, etc. initially had a similar price hike. These tape work out at 33% more. Because of the cut and thrust of the competitive market, you end up with multiple companies trying to get to the final tiniest bit of an advantage. So that means, mostly for commercial reasons, to be able to say this is different and better, come and buy new tapes and machines to use with them, they used a different time constant in order to flatten the response of the new tape and to peak sales of the equipment. To put it simply, they altered the tone controls within the set to give a better, flatter response, but it had to be a worldwide standard. They chose 70 microseconds, mostly because they could. The difference between using one to record and the other to play back is quite big. However, if you were to record a Chrome tape with Type 1 equalization, the difference in sound is minuscule. The effect is hardly noticeable compared to recording a tape with a Type 2 equalization. And that's where life becomes theoretically complicated. If you record tape with one equalization and play it back with the other equalization, the effects are huge. Think of it this way. If something has a plus or minus 5 value, that means that something can be minus 5 or plus 5. But the difference between the first number and the second number is 10. So what you think is only a 5% error can be a huge 10% error. Now if you take the tape as it is and record on it, we will give it a value of tape that equals plus 1. Equalization equals, say, minus 10. Tape plus Type 2 equalization equals plus 15. The difference between the two numbers is 25. But the difference between the tape and either one of the numbers is only a maximum of 15. As you can see, the numbers make a big difference. So it is not the tape that is the problem, it is the effects of the equalization not being the same. Maybe now you can see where I'm going with this. You can use either equalization on either tape, as long as you play back with the same EQ as you recorded it with. You would not be able to tell what was what by ear. You could tell which tape it was, but not what equalization was used. Obviously the Chrome would be less hissy and have a higher frequency response. This is a giveaway. If you record the Chrome tape with a Type 1 equalization but with the correct bias, it would expect to be played back on a Type 1 equalization deck. You may only get 99.9% of the quality that the tape could give you, but that value is going to be much better than the Type 1 Ferric tape could ever get. Quite simply, the Chrome Type 2 tape is better than the Type 1 Ferric can ever be. But it is not a Type 2, it is a Type 1 for playback. Therein lies the problem. They called it something. They gave it a name. And like giving food animals names makes sending them to the abattoir harder, naming functions gives problems later. Take SVHS input for example. Normal, Ferric, Type 1. This only means that the recommended EQ is 120 microseconds. The bias is in the standard range. CR02, Chrome, Type 2, high bias. This was decided to be the names used to mean the new tape, with a standardized 70 microseconds equalization. It is slightly less boosted because the tape behaves slightly better, but only when bias is much higher in value. The machines and the tapes were ready for the market, so they sold them, with names to easily describe the differences. Customers did not have to ask complicated questions. Just, will it do Type 2, CR02 tapes? The customer was happy, yes or no were the answers. Simple. After all the hype of Type 1 and Type 2, somebody sat back and thought, what can we do to make our pre-recorded music tapes sound better? We could use a better tape. Then somebody said to him, we can't do that, the machines have switches to tell them what the tape is. So he said, why don't we just put them in the tape case that tells it it's a Type 1, the same as normal tape? The other man said, what benefit would that give us? He replied, simple, a better tape would give us a better sound. And what's more, all the machines would be able to play them, and they would all get an advantage. And there will be no switches to fiddle with. And decks without switches wouldn't have a problem either. And so it was born, the Chrome Music Cassette. 99.9% as good as a Chrome recorded as a Chrome Type 2. But intended to be played on a standard non-Chrome deck, or if the machine has manual switches left in the non-Chrome settings. And if the machine has auto-sensing, the auto-sensor regards it as a Type 1. Hey, job done! But what about the EQ, I hear you say? Remember, you only need the replay EQ to match what you recorded it with. The same EQ. So play back a Chrome Music Cassette as a Type 1 and enjoy the full quality of that cassette. It is totally compatible. It is a Type 1. Now the dilemma. The only time the Chrome tape in a Type 1 shell is a problem is when you have a machine that auto-censors and you want to record it yourself. History again. Originally, Chrome Type 2 tapes came in the same shells as Type 1s. The notches for the autosense came later. So if you have an early machine and you want to play back a Chrome Music Cassette, you have to leave everything set to Type 1 position. If you want to record on that music cassette, you have to set it to Type 2. You need the extra bias if you want to get good recordings. The best results your machine can give you. Some machines had separate bias and EQ switches. You can see on this TIAC, which has two switches. One controls the EQ and one controls the bias. Now we get to the bit that I meant about don't overthink it. If you play back a pre-recorded commercial Chrome music cassette with Chrome Type 2 equalization on your machine, you will get bad sound. Simply it was recorded with Type 1 EQ. Why would you not play it back that way? If you have a Chrome music cassette that you want to record over and you have a machine with auto-sensing, your only options are to reproduce the notches in the shell or transplant the tape. In short, simply, a Chrome music cassette is going to be better than a Type 1 Ferric music cassette if you use it for what it was intended for. The only reason they tell you it's a Chrome tape is to benefit from the marketing. Otherwise you would think, wow, this tape sounds good. I wonder why. And the company that supplied it would get zero benefit because nobody would understand. But everybody knew the Chrome tape was better, so they wrote that on the box. Notice they did not put CRO2 or Type 2. That would have meant something different. On this tape they are telling you this is made using the best tape we can. Chrome tape, not Ferric. If you use it the way it's meant to be used, there is no problem. I hope all this made sense, and I hope you enjoyed watching this little myth-busting video. Please subscribe, comment, share, and like this video. Thank you for joining me. I really appreciate it. Any questions, please comment, and I'll get back to you. If you'd like any subject given the Gary Keep It Simple treatment, please put it in the comments, and I should do my best to cover it. Thanks again. Coming up later this week, TIAC W1200B playing PS Audio playlist, Paul's Picks, recorded from Spotify, recorded via USB to Audacity. Cheers. Let's keep life simple.